Okay, so today we're learning 4.2 prime factorization for all the bots in the world to learn. Okay, 4.2 prime factorization. Okay, now I know for a fact you guys learned this last year. Okay, who remembers factor tree? Okay, factor tree.
Aren't we just going to do this right now?
Yep.
Yeah.
All right, so prime factorization. To find prime factorization, we're going to do what's called a factor tree. And what that does is it shows you all the prime numbers that go into a specific number, okay? If you take all the prime numbers and multiply them together, it gives you the number that we're dealing with, okay? You can go back and forth, everything. The reason we learn how to do this is because it will help us find the greatest common factor and least common multiple, which are learning tomorrow and the next day, much easier, okay? So when we're doing factor tree, again, this I'm teaching you or reminding you how to do this to get ready for greatest common factor, Kelly, get off your watch, and least common multiple. Well, quit picking on your skin. Pay attention here, not your skin. I am more interesting than your skin. Okay, so for example, 42. I'm doing it over here on this side. Okay, 42. So if you remember how to do this, great. If not, if you never learned, you're about to learn, crash course. If you did this but you forgot, this is going to be a great reminder. Okay, so let's say I want to know what are all the prime numbers that go into 42. Atalia?
Well, I was thinking of numbers, not prime.
No. Let's go ahead and do the factor tree.
Okay, so 21.
So what you do is you see what two numbers when multiplied give you 42.
21 and 2.
21 times 2. Now, is 2 prime?
Yeah. Yes.
Yes, it is. So we're going to circle it. Follow my lead on this, okay? There's reasons to my madness. If you circle it, you'll be happy. Atalia is 21 prime. Yeah. And remember, prime means no other number can go into it besides 1 in itself. So Atalia, what two numbers when multiplied give you 21?
7 and 3.
7 times 3. Is 7 prime?
Yes.
So we're going to circle it. Is 3 prime? So we're going to circle it. Before I move on, Tanner, do you have a question?
Yes, ma'am.
Okay, what?
When they mean prime, does it mean like no other number can go into it?
That's right.
Okay.
So like 3, only 3 and 1 can go into it. 7, only 7 and 1. Okay? Like 21 is composite because its factors are 1 and 21, but also 7 and 3. Does that make sense? Okay. So now that I have those circled, here's how you write it. You're supposed to write it from least to greatest. Now watch what I do, guys. You're only writing the prime numbers that you circled. 2 is my smallest, so I'm going to write 2, and I'm lightly crossing it out. The next one is 3, but you do multiplication and cross out the 3. You have to have the multiplication in between there. And you cross each one out. Okay, so look what I did. I listed my prime factors that I circled in order from least to greatest, and I crossed them out each time. Let me explain why. You're going to have some numbers where they're going all over the place. If you do not circle them, you're going to accidentally leave one out. If you do not cross each one out as you're doing it, you may, again, leave one out and your answer is wrong. Okay, so you got to be careful. The reason we have the multiplication between, because what is 2 times 3? 6 times 7 is 42. See how that works? Okay, let's say what are two other numbers when multiplied give me 42 besides 21 and 2? Tanner?
12.
Does 12 go into 42?
No, it doesn't. Okay.
All right. Italia?
76.
Okay, so we can do 7 times 6. Now I want you to stop and look after you write this down. This one, Italia chose 21 times 2, and we worked it out correctly, and we listed our factors, right? But what if she chose, which she did, instead of 21 times 2, 7 times 6, because 7 times 6 also gives us 42, right? If you do it correctly, it will work out. So it doesn't matter each time which two numbers you put down, as long as they equal whatever it is you're looking for and you solve it correctly. Okay, so Talia, is 7 prime?
Yes.
Is 6 prime?
No.
Okay, so what two numbers give us 6?
2 and 3.
So 2 times 3. 2 is prime and 3 is prime. So I'm going to write them down. 2 is first because it's least, and look, I'm crossing it out. 3 is next, and then 7. Now notice the difference. Is there a difference?
No.
No. This was a hard concept for the 6th graders to get past, is that it's okay to have different numbers right here when multiplying to give you the same thing. If you do it correctly, you will get the same prime factorization. Do you see that? So this is the answer, and this is the answer, same thing. So if they ever say, what is the prime factorization of? This is what you're trying to get to.
Are we allowed to ask them because like what do they mean by prime factorization?
I've had some of the 6th graders said that, and I'll say factor tree. Oh, okay. Because sometimes you kind of forget what the directions are asking for. Any questions before I move on? Okay. If the same prime number occurs more than once, use exponents to indicate the number of times each factor occurs. And I'll explain that to you in just a minute. If the same prime number occurs more than once, they're referring to like the 2, the 3, and the 7. If you have more than 1, 2, or 3, or 7, or a 5, you will use exponents to indicate the number of times each factor occurs. And I'll tell you, I'm really proud of the 6th graders. They're nailing this one. And I mean, really, I didn't expect the 6th graders. I didn't even take off on their tests. I'm like, if you give me this, I'm not taking off. But they went ahead and put it all in exponents, and I was really, really proud of them.
So like 2 to the 2nd power.
Well, yeah, and I'm about to show you. Does everyone have this down?
Yes.
Kelly?
No,
Okay. Tanner, you need to finish your drink.
I don't want it, honestly.
You don't? Okay, then when we're done, I'll let you go pour it out. Don't force yourself to drink if you don't like it. Okay. Let's do the prime factorization of 90. So besides Italia, someone else, because you did the last one, Kelly, what two numbers when multiplied give me 90?
9 times 10.
Okay, 9 times 10. You could choose other numbers,
45,
or 30 times 3. There's many different ways, but you just need 2, okay? And again, like someone else might solve this a different way, but your end result will still be the same. Okay, so Kelly, is 9 prime?
Yes. No.
Which is it? So listen. Prime means only one and itself can go in there. Is there another number that can go into 9 besides 9 and 1?
Yes.
So then is it prime?
It is not prime.
It is not prime. So we're going to do another little treat thing. How about 10? Is it prime?
It is not prime.
That's right. So I'm doing another thing there. Okay, so Kelly, what two numbers when multiplied give me 9?
3 times 3.
There you go. Is 3 prime, Kelly?
3 is prime, yeah.
It is, because only 1 and 3 can go into it, right? So we're going to circle my 3's. So, Kelly, what two numbers when multiplied give me 10?
2 times 10. 2 times 5.
All right, is 2 prime?
Yes.
Because only 2 and 1 can go into it. How about 5?
Yes.
It is, because only 1 and 5 can go into it. Okay, so we've come to the end, right? Okay, so we're going to write our prime factors from least to greatest, from least to greatest, from least to greatest. So I have 2 times 3 times, oh, here's another 3 times 5. Do y'all have this?
Yes.
Any questions so far?
Why didn't we do that?
First things first, you write them out normal. Trust me when I tell you. Now, we can write them with exponents. How many 2's do I have?
1.
Now, this, when they say prime number occurs more than once, how many 3's do we have?
2.
We have 2, so I'm going to do times 3 to the second power, because I have 2 3's. So therefore, I do that exponent. And then times 5. And there's your answer.
I think there's also neat.
Are there any questions? No questions? Everyone have this down?
Yes.
All right. So, open up your book. To page 143. Okay, it says find the number whose prime factorization is given. Okay, so number 2, they gave us 2 squared times 3 times 5. Do y'all see that?
Yes.
Make sure you write all this down. So, Joseph, what is 2 squared?
4.
And then I have 3 times 5. So what we're doing is we're multiplying it out. Joseph, what is 4 times 3?
12.
All right, so I have 12 now times 5. See what I'm doing there, everyone? Joseph, what is 12 times 5?
60.
And he is correct. Are there any questions on how to do this? You got to remember your exponents. That's not, and guys, that's not, that is, remember, that is 2 times itself 2 times. For example, what if I have 3 squared? Atalia,
9.
why is it not 6?
That's plus, well, that's times 2, not times 3.
That's right. We do not do 3 times 2. That is 3 times 3 equals 9. Do y'all see that? Be very careful. I have students that'll tell me 6 all the time. Okay. Any questions on how to do that? All right. Number 8. Let's drop down to number 8. So number 8, all they say is write the prime factorization of each number. So I'm going to do 8 is 28. So Tanner, I'm going to let you work on this one. So tell me, once you have it written down, think about it, what 2 numbers when multiplied give me 28?
7 times 4.
Good job. 7 times 4. Good job. Now, you ask yourself, is 7 prime? Yes, it is, because only 7 and 1 goes into it. Is 4 prime? Correct. So what 2 numbers give me 4 when multiplied?
2 and 2.
So 2 times 2. Is 2 prime?
Yes.
So we circle both of those. So I'm going to write 28. And tell me what to write down here next to it.
7. 2 to the 2nd power. Which is
First, we're going to list it out. So we have 2 times 2 times 7. Now, Tanner.
2 squared times 7.
Perfect. Perfect. Any questions? Everyone good?
Oh, sorry.
Do you have a question?
No, it's super.
All right, let's see. Let's go to number 16. Okay, this is just like what we did in section A at the very beginning, but they're taking it up a notch. They gave you the prime factorization, and you have to figure out what number it is. Atalia, you want to try this?
Yes, ma'am.
All right.
So you do 3 times 3, which is 9, and then you do 9 times 3, which is 27.
Okay.
And then you do 5 times 5,
Which is?
25.
Now I'll let you work on what 27 times 25 is. And the rest of you, do y'all see where she got her numbers?
Yes, ma'am.
675.
675. I always tell my students to just write it out, making sure you keep, the multiplication symbol there, and then just, Any questions? All right, let's look at 22. Joseph, you want to do this one?
Sure.
308. They want the prime factorization. See, they're taking it up a notch, a little bit harder. Now you'll understand why I say circle them. So Joseph, when you're ready, tell me what two numbers you would use.
2 times 154.
Yes, 2 times 154. Now, guys, this is where the divisibility rules would come in very handy. Because if you look, that number is even. So we know, because that last digit is even, that 2 will go into it. So that's a good place to start to bring that number down a little bit smaller. Okay, so he was like, okay, I know it's even, so 2 goes in there. And then he divides it out to see how many times it goes in there 154 times. Is 2 prime, Joseph?
Yes.
Circle it. How about 154?
No.
All right. So what two numbers when multiplied give you 154? And again, you can see that this number right here is even, so we know what number will go into it.
2 times 77.
2 can go into it because it's even, times 77. Good job. And he said 2 is prime. Joseph, is 77 prime?
Yes. No.
You're correct. So what two numbers give me 77?
Seven times 11.
Yep. 7 times 11. Is 7 prime?
Yes.
Is 11 prime?
Yes.
Very good, because only one 11 could go in there. Okay, so we write it out. What comes first? Joseph?
2.
Cross it out, times.
2.
Cross it out, times.
7.
Cross it out, times.
11.
Very good. Now write it in exponential form.
2 to the second power.
Times
7 times 11.
Perfect. Any questions? No questions? All right, let's do one more. Does everyone have this down? Okay, again, divisibility rules. Number 30. 525. Tanner, you want to try this one? All right. So again, if you look at that last digit, that's helpful.
5.
5 can go in there. Times, now you got to go off to the side here and figure out how many times.
15.
5 goes into 5 how many times? Bring down your 2, right? How many times 5 go into 2?
0.
You got to put that 0 up there.
Okay.
Bring down the 5. Now,
1 time.
5 goes into 25.
15. 5 times.
So what's my answer? There you go. Be real careful. Okay, so is 5 prime?
Yes.
So I circle it. How about 105? Correct. So, again, look at that last digit.
Or 5 times 21.
There you go. 5 times 21. And we know 5 is prime. Is 21 prime?
No.
All right. And what two numbers give me 21?
7 and 3.
7 times 3. And those are both prime. All right. So now we write it out. What comes first?
3.
Very good. Times.
5.
Cross it out. Times.
5.
Cross it out. Times.
7.
Very good. Now write it in exponential form. What do you get as your final answer?
3 times 5 squared times 7.
Perfect. Perfect. Any questions? All right, I'm going to set you free. 143 to 144. You will do 7 through 13 odd. 21 to 29 odd. And 47 to 51 odd. This is due Tuesday. Your quiz is Monday. And I am going to be assigning some IXL. It will probably be due like Monday of next week, maybe later. Let's see, no. Probably later.
I've already done some of the Excels for chapter 4.
I've
Good.
done 1 for chapter 4.
Okay, good.
I did 2 of them.
It'll probably be due. I'm gonna have it due Tuesday.
I did them
Okay.
this next Tuesday, right?
Yeah. Not tomorrow.